Hey guys, we are looking at section 11.8 and complex fractions. This section could be a little overwhelming, so I'm hoping that in watching me go through these that you'll see the individual steps that I do, that it's not, try not to look at the whole page like when I get done and think, whoa, that's way too much. Think about the little steps that I did. So to start off, we're going to do the same problem two different ways to show you that there are different ways of doing them depending on what you're most comfortable with. So in this first one, we're going to use order of operations and just all the basic math stuff that we already know how to do and treat these for now kind of individually. So I'm going to look at this top part and I want to combine these. So that means I need to have a common denominator. So I'm going to multiply the x by 3 over 3 because that gives me 3x over 3. And over here I have x over 3. So now I have a common denominator. So I can add those. So 3x plus x is 4x over 3. Okay, I just added my numerators and I kept my denominator the same. Okay, now I'm going to look in the top and the bottom at my denominator. That's its own rational expression here that we have with our 2 over x plus 5. So I'm going to look at this. I'm going to multiply this by x over x. So I have 2 over x plus 5x over x. So now I have a common denominator. Okay, all I did was multiply by 1, but that was to give me a common denominator. So now, again, I'm ignoring the top, okay, and I'm going to combine these. So I have 5x plus 2 over x. I can't do anything else with that because 5x and 2 are not like terms. Okay, so now I'm going to treat this like it's a division problem. Because that's what it is. Remember, it's this divided by this. And when I divide fractions, I write my first fraction, I change it to multiplication, and I flip my other fraction. So my x is going to go on top, and my 5x plus 2 is going to go on the bottom. And now I'm just going to multiply. So I have 4x times x is 4x squared. And 3 times 5x plus 2 is 15x plus 6. And in this process, at one point, well, a couple points here, I have x's in the denominator. And at the end, I don't have an x by itself as a factor. I have 15x plus 6, but not just x by itself. So I need to remember that x cannot be 0. Okay. Because I had it up here as a factor. Okay, now that's one way to do it. The next way is going to seem a little bit strange, but it's actually way, way more efficient. So you just have to stop and think about what you're doing, take it in steps, and follow what I'm showing you. Okay, so I want to look at my top, which is kind of like your numerator, and my bottom, which is my denominator. And I want to look at what denominators are in the top besides 1, because this is over a 1, but I don't care. And this is over a 1, and I don't care. Okay, so in the top, my denominators, I have 3. And in the bottom, my denominator is x. And we've learned in the last couple of sections that the least common denominator is the product of the most a factor shows up in any one thing. So it's all my factors and the most that they show up. So the most 3's in either of these is 1, and the most x's is 1x. That's my least common denominator. I found that not to do what we've been doing, but I found that so that now I'm going to multiply this by a fancy 1 using my least common denominator. So I have this fancy 1, and I'm going to multiply it by x plus x over 3 over 2 over x plus 5. Okay. Trust me in what I'm doing. Even if you're like, why are we doing this? Remember, with math, sometimes we have to be creative. And the creative thing we're doing right now is we're picking a very special 1 to multiply by. And that doesn't change anything. It's just going to change the way it looks to make it simpler for us. So I'm going to distribute my 3x over this top expression. So 3x times x is 3x squared. And 3x times x divided by 3, if you look at that here, that's 3x times x divided by 3. Those 3's cancel. So I just have x squared. And then down here, 3x times 2 over x. Look at that here. 3x times 2 over x. My x's cancel. So I have 3 times 2, which is 6. And I'm going to write that over here because it's adding. It doesn't matter. And I'm going to do 3x times 5. It's 15x. So now when I combine these, I have 4x squared on top, and I have 15x plus 6 on the bottom. And notice here I have an x in the denominator that doesn't show up as its own factor. It's here, but it's not its own factor here. It's part of 15x plus 6. I don't see this anywhere though. So I know that x cannot be 0. Now if you look at my 2 answers, they are exactly the same. I did it 2 different ways. Look at the work I did here and how many steps I did. And look down here. This is going to be more efficient. Also, if you're doing an equation, you're solving an equation. We're not solving equations here. We're simplifying expressions. If we're solving equations, this is the better way to go. So, however, sometimes just the goal is to just do it, and however it works out is how it works out. Okay, we're going to look at one more example. So this is 11.8c. And we're going to use the least common denominator method with this one, so I can show you again, on the big scale, it's daunting. On the small scale, when I'm looking at each little piece individually, it shouldn't be that bad. Okay, so here is my expression. All right. Now, some of you might think, hey, there's a 1 over x minus 1 here and a 1 over x minus 1 here. Can I cancel those? No. You can't. Stop and think about that. I can't do it because this is subtraction and adding, not multiplication. Okay? If it was these things multiplied by these things, that would be different. But because these 2 things aren't being multiplied, and these 2 things aren't being multiplied, I can't do that. Okay, so get that out of the way. Take it out of your head. Okay, so I am going to follow what I did before. I'm going to look at the top by itself and think, what denominators are there? I have x plus 1 and x minus 1. In the denominator, the bottom, this whole thing, what denominators are there? X minus 1. My least common denominator is the product of every factor, the most amount of times they show up in one thing. So in here, the most x plus 1s I have is 1, and in here I don't have any. So the very most is 1. And in either of these, x minus 1 only shows up once in either of them. Okay. So this is my least common denominator. Okay, you're not going to like this, but I don't care. I'm going to take my least common denominator, and just like I did last time, just this time I have a funky fat one, I am going to write x plus 1 times x minus 1 over x plus 1 times x minus 1. Don't distribute it because we're going to have some canceling happen that we want to happen. So don't factor it yet. Leave it like, or it is factored. Don't distribute. Don't simplify this. Leave it like it is. Okay? All right. And I'm going to multiply my fancy 1 using my least common denominators to make it by this. So I'm going to look at the top first. I have 1 over x plus 1 minus 1 over x minus 1. And in the bottom, I have 1 plus 1 over x minus 1. Okay. X plus 1 times x minus 1 is just a number. Because it's written as a product like that, think of it as one number, and I'm going to distribute that over my top expression. So I have x plus 1 times x minus 1 times 1 over x plus 1 minus, because that's a subtraction, and I'm going to do that over here, x plus 1 times x minus 1 times 1 over x minus 1. I'm going to do the same thing in the denominator. This is just a number. I'm going to distribute it times 1, keeps it the same. And I'm going to distribute here. X plus 1 times x minus 1 times 1 over x minus 1. Okay, now this term, everything's being multiplied. This is in the denominator and this is in the numerator. So I can cancel those. So I'm left with x minus 1. Subtracting here, x minus 1 and x minus 1 cancel because 1 is on top and 1 is in the denominator. So I'm left with x plus 1 over, I have x plus 1 times x minus 1 plus, here these cancel, so I have x plus 1. I'm going to rewrite that. X, minus 1 minus x minus 1 over, and I'm going to write this as x squared minus 1 now. Remember, these are conjugates. And when you multiply conjugates, you get the difference of two squares. Okay, if you FOIL that, you get this. And then plus x plus 1. So I did this now because I can't do any more canceling with that. So I did that now. Now if I go to the top and simplify the top, okay, just look at the top. This is easy stuff. X minus x is 0 and negative 1 minus 1 is negative 2. Okay, that's stuff we learned how to do a long time ago. Every single step here isn't so bad on its own. So always remember to go back to each little step. Okay, now in my denominator, I have a negative 1 and a positive 1. So that's 0. And I have x squared plus x. Okay, now you could leave that, but it's going to be best if you factor that denominator because you're going to be able to see things a little bit more clearly. So I factored that out. I factored the x out. And so that's what I have. Now, I need to think about any values that I excluded that I need to be paying attention to. Any values to exclude. So I go back up here and I want to think about what were my denominators, x plus 1 and x minus 1. Those were my denominators in the original. X minus 1, x plus 1, x minus 1. Okay, down here in my answer, x minus 1 doesn't show up. And because of that, I've eliminated this possibility here of x being a 1 and that making this 0. And I can't have that. I can't have x be 1 because 1 minus 1 would be 0, and then this would be 1 over 0, which is a no-no. So, and remember, all I'm doing is looking here. Look at your factors that you had, x plus 1 and x minus 1. Is there anything not represented here? X minus 1 is not represented. So x cannot equal 1. Okay? These aren't easy. I would never ever say these are easy. However, I want you to stop when you're doing them and take each step as I've showed you. Look at the top. Write your denominators down. Look at the bottom. Write your denominators down. Come up with your least common denominator. Make it a fancy 1 by putting it on the top and on the bottom. Distribute it, and then start simplifying. They're all going to look a little bit different, so it's hard to show you, any kind of example that's going to help you. You're going to have to try them out. If you want help, I want to see what you've done. So make sure you take a picture of what you've figured out. Don't show me a problem and say, I don't know what to do. Put in the effort. Write down whatever you can do. Write it down. Figure out what your denominators are in the problem and write those down for me. If that's all you get, that's fine. But that shows me that you're trying to do something. Okay? And do all the blues. Okay? Because especially now that we're not going back to school, we need to make sure that we're getting all of our stuff done and we're understanding it so that you'll be fine for next year. To move on to the next class. So, anyway, I think that covers it for this week. I have us paced out so that we will get done for the end of the year. So, for some of the weeks, that'll just be doing 3 lessons a week, which isn't too bad. You can pace those out for yourself. All right? So, let me know if you have questions. I am happy to help you. And I will talk to you later. Bye.